All right, page 77, 3.7, computing with numbers. This is number 12. Write a program to find the sum of the cubes of the first n natural numbers where the value of n is provided by the user. All right, so we're going to find the sum of the cubes of the first natural numbers, not the sum of the first natural numbers. So this program calculates the sum of the cubes of the first natural numbers where the value of n is provided by the user. Okay, so this is going to be sum cubes dot pi, and this is going to be by Michael Hoft. All right, so this is similar to the one we just did. It's a little bit different. So let's see. Okay, so we're going to define our function. I guess we could use the same. I don't know what the. I guess it probably depends on who you're talking to, what educator or manager you're talking to, but I don't know if you should use the same definition name or the same function name as program name. So let's just say, we'll just call it cube sum. Cube sum. So cube sum is going to be, so then I'm going to call this out. All right, so def cube sum. All right, so this is going to be the cubes of the first natural numbers. Okay, so we're going to do for x in, so this is going to be num, and then here we're going to call it a num. So a num equals so for x in range 0 num plus 1. So for x in range 0 num plus 1. We're going to go to so we're going to initialize our variable sum starting at 0 because we're just adding them, right? So we're just going to keep updating it starting at 0. So 0 plus some number plus, and then that number is added to the next number, and that's reassigned to sum, and then that's how sum gets bigger and bigger. So where we add those up. So sum equals sum plus this is going to be x cubed. So we're going to do x cubed, a little bit different than before because we're trying to find the cubes of the first natural numbers. Now, since we're summing them, it doesn't matter about the 0, right? Because we're just going to keep adding. So it's not like we're going to keep getting 0. If we were multiplying them, we'd have to figure out what to do with that 0 because the 0 is going to keep, you can multiply any number by 0 and you're going to keep getting 0. So that's going to have a faulty output, which I believe is a syntax error. I'm still learning the errors. but I believe that will be a syntax error. So I think this is it though. Sum equals sum plus x cubed. So the definition of cube sum with num as our argument, sum equals 0 for x in range 0 and num plus 1, sum equals sum plus x cubed. Okay, and then we're going to return our sum. So that's going to be our return value. So a num equals, we're asking for an integer, so let's make that an int, equals input, please. Enter a non-negative number. Let's just put integer, make it very, very clear. Please enter a non-negative integer, and I will calculate the sum of the cubes of the first natural numbers from 0 up to your number. Okay. Two closing parentheses. And then we've got our function call here, our invocation of the function. We can also change this to a print statement. So let's change this to a print statement. And let's see. All right, let's run it. So this is some cubes. So we're going to find some cubes. All right, here we go. Cube sum, return sum, cube sum, a num, num. I think we should be good here. And this is x cubed. Also, we want to think about math, the math library. So we don't need to import math because I believe that these two asterisks are just part of regular Python. Just in terms of the exponent. I think if we used POW, P-O-W, I believe that is part of the math library. So I think we're okay here. And I think that would make it run a little bit faster. I'm also learning a little bit as we go along about, about like speed and because as obviously as programs get bigger, they get more heavy in terms of speed. So you want to keep that speed optimization and efficiency in a good place. So let's see. Let's run this. All right. So let's do 3. So 36. Okay. So let's think about this. 3 cubed is 27. 2 cubed is 8. 27 plus 8 is 35. 1 cubed is 1. 35 plus 1 is 36. Excellent. All right. So now let's try 0. Okay. What else? Let's see what this is. Let's try 100. So it's 2, 550, 2, 500. Interesting. So the sum of 100 numbers was 50, 50. And now we're at 2550, 2500. Kind of interesting. Very, very close to an exact, very, very close to an exact number like the 50-50. But I don't know, just kind of interesting to think about 2550, 2500. But yeah, so we would obviously try this a bunch of times and try and then make sure that they were right. I mean, we could obviously go the lower ones, you know. Let's see if, well, what do we think it'll happen? That's another thing we can do too, is play a little game, right? Like, what do you think it'll happen if you put it in a negative number? Well, if we're going from 0 to a negative number, it's probably going to be an error here on this line. Because, well, actually, if it's -1, we're going to go from 0 to 0. We should probably get 0. Because I don't think it'll go beyond. But let's just try. Let's just pick something outside of the bounds, just because, just to see. And 0, yeah, okay. But if you put -2, that's something different. So -2 is going to be from 0 to -2, sum equals sum plus. So -2 cubed is going to be -8. -2 cubed is going to be -8. But I don't think that's going to work here. I don't know. I don't know enough about this range function yet. I'm pretty sure that it goes positive, so it's supposed to, but I'm not sure. This I think is really helpful too, because it teaches you about these functions, what they're capable of. So let's do -2. Oh, it's 0. So we're going to keep getting 0. So let's see. 0. So 0. So obviously we can look it up, but let's see if we can figure it out before we look it up. So if we did -2, -2 plus 1 is -1. Right? 0 to -1 is still 0. I think if we go to -3, we might get a value that's a non-zero value. I think that's why. All right, so let's go to -3. Oh no, they're all going to be 0. So all of these negatives are going to be 0. Okay, so some of you guys are probably just yelling at the screen or clicking off this. No, I don't know. We're learning something new. I definitely want to go over the discovery process with you guys as well, just with how I look for information and how how I discover new knowledge as well. So let's see. This program calculates some of the cubes of the first natural number to survive and is provided by the user. So sum equals 0 for x in range 0. So let's see. So let's see. So if it's negative, let's say this is -1,000,000. It goes from 0 to num plus 1. The sum equals the sum plus. I think we got to look this up. Very interesting. So the range function Python. Let's go over this. Let's check out the docs. So we're going to go to 3. So let's check out the range function. Start, stop, step. It's immutable. So class range. So let's see. For a negative step, the context of the range is determined by the formula Ri. So the range object will be empty if R index 0 does not meet the value constraint. Ranges do support negative indices, but these are interpreted as indexing from the end of the sequence determined by the positive indices. So here, this is fine because we're starting at 0, going to -10, and going by -1. The other alternative, obviously, well, we would obviously like look up a whole bunch of stuff, on range, but then also I could ask an expert, or the prof, if we had, this class with Professor Zelle, or a TA, or there are a lot of resources. You just, it's really helpful to learn this stuff because it's going to come up a lot, especially if you're swimming in this this stuff. I mean, because this stuff comes up in probably every major language. I mean, C++, and just, so you want to know, like, why does it spit out 0? So sum equals 0 because it's a sum. So you're going to add up. Maybe it thinks it's going to be positive. So I'll probably ask about this. This is very important. But anyways, I think we did the program right, and we did tell them to write in a non-negative integer. The other thing is we can code the program so that if it punches in a negative integer, that we keep that loop where it spits out another prompt that says please enter a valid number. So that's another thing that we can do to protect ourselves. But I still am curious about the negative number, so I'm going to ask, and hopefully I'll put it in the notes for this video, or I'll have that information in a PDF or whatnot for this class. Very important stuff. And that's the other thing too, is just having a curiosity, like being curious. I think is a real big plus with regards to just life, but just learning. When you're learning something new, whether it's like car repair, which I'm learning, not super new, but pretty new. And I've got buddies of mine that they're just experts. They've just spent, hundreds, if not thousands of hours, checking out cars. I mean, like one of my buddies is a mechanic. He works at, he does it all day long. He sees cars all day long, and he's underneath the hoods all day long. But even a buddy of mine, he got just really, really good at it. And so whether it's something that's technical or something that might help you in terms of survival or in terms of self-sufficiency, even if it's like cooking, even if it's, shopping, or, there's just so many health, exercise. I just think that having a curiosity about your field is just a value in and of itself. It doesn't have to be, where, oh, well, I'm only going to learn enough so I can answer these questions in this book. And that's the other thing I want to make clear, is that, that's kind of like doing the minimum amount of work at your job. I'm not saying that, you should drive yourself crazy. Of course not. But what I'm saying is just that this attitude of curiosity, of like, let me find out, like, let me test this, let me really, go back to this program and try to improve it, or, see where what happens when you punch in the outlier conditions, or what happens when, there's a user error. I know that I was talking to some buddies of mine in industry, and they work for a big enterprise company, and in the IT field, and they say the biggest issue that they come across in a production environment is exceptions handling. It's just like handling these exceptions. So, that's something that, obviously the program should help protect the user against himself, if at all possible. Um, um, and again, this is, this is all sort of being formulated right now. So it's not like something that I have like a fully baked cake. Like I'm still, you know, learning this stuff as we go as well. But it's a really good exercise for me as well to go over this stuff and share what I know, and then share the questions that I have, and yeah. So hopefully we can get that question answered. I want to I want to figure that out. You punch in a negative, you've got 0, and then num plus 1, but on the negative, it's but this x cubed, supposedly if you punch in you know uh 1,000. I mean, let's just try it, right? Let's just try 1,000. Let's do negative 1,000. They're all 0. They're all going to be 0. So I'm going to find out, and I'll put that in somewhere where you guys can find it, where I've solved this problem. All right, thank you very much.